Okay, today we'll be doing effects of transformation on MCT and MOD. So what is MCT and MOD? By now all of you should be well versed. MCT is mean, mode, median. MOD is range, interquartile range, and standard deviation. Okay, so our learning outcome for this would be recognizing transformation. What is transformation? Basically is when you make a change to your data. How do you change your data? Basically you're transforming it. Then you add or minus something to your data, or you times and divide something to your data. So let's say if I plus 2 to my data, what will happen to my mean and standard deviation? Will it also be added by 2? Okay, or you multiply 3 to your data, what will happen to your mean and standard deviation? Do you have to recalculate everything? Well, no. That is why we are learning transformation. You don't need to change your whole set of data. You will just need to learn how to sort it out. Basically, you just do the changes on your mean and standard deviation. So your original data will be known as X or Y or Z or whatever it is, whatever they give you in the question. And your data after transformation will have a prime there, as you can see. Okay, your data after the transformation will have a prime. So you must know how to basically recognize transformation and write your transformation equation, which we will go through later. Okay, there are two types of transformation. One is change of origin and one is change of scale. Change of origin is when you plus and minus something to your data. Meaning when you add 2 or you minus 2 or something like that, that's change of origin. Change of scale is when you times and divide your data. Okay, so we're going to cover all the 3 points today, basically all the 3 learning outcomes. Recognizing transformation, recognizing the 2 different types of transformation, what sort of transformation you have, and the effects of transformation on MCT and MOD. Basically, what will be the effect on the MCT and what will be the effect on the MOD. MCT is mean, mode, median. MOD is range, interquartile range, standard deviation, and variance. Okay. So now this will be how your transformation formula will actually look like. COO is change of origin. Okay, why do we call it change of origin? I will show you in a while. So change of origin is when you plus or minus something to your data. Do you see that? X prime, that means your transformed data is equals to the original X plus or minus something to your data. In this case, we are using A. So if you look at this, this is your old scores. Do you see the old score there? 1, 2, 3, 4. Now what you're going to do is you're going to add 5 to your data. So now when you add 5, that means each one of your data will be added by 5. Do you have to recalculate everything, meaning go and change your whole data add by 5? No, you don't need to do that. So what will happen is this. I will show you technically what's going on, and then I'll also show you how do you handle the MCT. So if you look at this, when you plus 5, what will happen? Your 1 will become 6. Do you see that? Your 2 will become 7. Your 3 will become 8. You add 5, isn't it? Your 4 will become 9. So why do we call it change of origin? Because the original shape of the distribution doesn't change. Do you see that? It was originally on the left, now it just moves to the right because it's added by 5. So what can you see from the histogram is, of course, your mode, you look at your mode it was 3, right, originally. You plus 5 to your data will become 8. So you will just, the mean mode median will go through the whatever changes. If you add 5, your mean mode median also add 5. Minus 3, your mean mode median also will minus 3. But there will be no effect to your MOD. Why no effect? You can see the shape of the distribution, the dispersion didn't change. They call it change of origin because the distribution will look originally the same. It won't change, it will just move. If you add, it will move to the right. If you minus, it will move to the left. Therefore, your mean mode, when you plus and minus something to your data, your mean mode median will follow. But MOD, no effect. This is where students always go wrong. MOD is what? Range, interquartile range, standard deviation, and variance. When you plus and minus, no effect. I have already shown you here why no effect. Okay, then you have change of scale. What is change of scale? Is when you times or divide something to your data. So now I will show you what's going on here. Okay, so if you look at the original histogram, 1, 2, 3, 4 is your data, isn't it? Correct or not? Okay, 1, 2, 3, 4 is your data, isn't it? So now when you times 2, it will be 2, 4, 6, 8. Can you see that? 1 will become 2, 2 will become 4, 4 will become 6, 6. Sorry, 3 will become 6 and 4 will become 8. Can you see that? Why do they call it change of scale? Because the distribution doesn't remain like its original anymore. everything has changed. Your scale also changed already. Meaning your MCT also will change, isn't it? If you look at your mode, initially it was 3. What happened now? Becomes 6. So your mean, mode, median also, you times everything with 2. If you times the data with 2, mean, mode, median times with 2. MOD will also times with 2. Range, interquartile range, standard deviation, you times with 2. But variance, do you see that box there? Variance, you will times with 2 squared. Do you understand? Your variance will be times with 2 squared. Look down there in the box. Range times 2. Standard deviation times 2. Interquartile range times 2. But variance times 2 squared. If you times 5 to your data, variance you times 5 squared. Do you understand? Okay, moving on. This is in your manual as well. So what you can see here is basically the old score and new score, exactly the same thing that I've been showing you, but put it into a table. Okay, it's the same thing in your manual. Why one is change of origin, one is change of scale. How do you affect the MCT and how do you affect the MOD? So just remember one thing: when you plus and minus something to your data, your MCT will also plus and minus by the same. But if you times or divide something to your data, your MOD also will go through the same times and divide. MCT and MOD both you times. Okay, so when you plus and minus, MOD no effect. So the only one time it won't change is when you plus and minus, range, interquartile range, standard deviation, variance, no change. You understand? Okay, so now what I want you to do is I want you to try this table here. Okay, so if you try this table here, what are they doing here is they've given you the data, the original data, 1, 1, 2, 3, 3, 3, 4, 4. So now they are saying on the left, they want you to plus 5. On the right, they want you to times 2. So please don't go and recalculate everything. You just find the original values for me first, like what you see in the middle here. This is the original mean, original median, original mode based on this original data here. Original range, interquartile range, variance, and standard deviation. Then what I want you to do is add 5. So if you add 5, what will happen? Your mean also will add 5. Your median also will add 5. Your mode also will add 5. But range, interquartile, all these, no effect. Now if you times 2, what will happen? Your mean also times 2. Your median also times 2. Your mode also times 2. Okay, everything times 2. Okay, but what about your MOD? Range will also multiply 2. IQR times 2. Standard deviation times 2. By your variance, you will multiply it with 2 squared. Alright? Okay. Okay, can you use your time to complete this table? Alright? This table and the exercise 1.4 question 1, you should be able to complete it. You should take about at least 20 minutes to complete this because it's quite a big table. I would appreciate it if you don't copy the answers. Just try it. What's going on here is what you see on top there, the 1, 1, 2, 2, 2, 3, 5, 5, 10. These are the original data. Okay, this is the original data. The row that is right on top is original. But A, B, C until J, the data has been changed. They have transformed the data already. There's been a transformation that is going through there. Okay, you need to write down the transformation equation in the next column that you see there. Okay, you need to write down. So I'll teach you one example here, and I want you to work it out on your own. Okay, so let's see. Can you see what happened here? From 1 becomes 0. From 2, it will become 1. From 3, it will become 2. From 5, it will become 4. 10, it will become 9. So what's going on inside here? It is being reduced by 1, right? So the transformation equation will be x minus 1. You understand? Why minus 1? Because it reduces by 1. So x minus 1, what kind of transformation is this? COO, change of origin. So when you minus 1, can you see your mean also minus 1? Median also minus 1. Mode also minus 1. But what will happen to your range, interquartile range, standard deviation? No change, because plus and minus, MOD, no change. Same goes to the second example. So I want you to take about 15-20 minutes to complete this. So there are some here, there is a mixed transformation like this. 10x plus 1. That means the data has been multiplied by 10 and added by 1. So when you're doing this question, you've got to be quite careful. Mean, mode, median, you times 10 and plus 1. It will go through both the transformation. Whereas for range, interquartile standard deviation and variance, only times 10. You will not plus 1 because plus minus no effect. Okay, so you must be very careful when there are two transformations involved, times and plus. You will, for your mean mode median, you'll go through both, you times, you plus. But for your MOD, you only multiply. Understand? And then there's also a transformation here where you have a negative, where you times a negative value. Okay, your mean mode median will follow and become negative, but your MOD cannot be negative because first of all, standard deviation no way is negative. Okay, your range also cannot be negative. What is range? Distance from the biggest data to the smallest data. Distance cannot be negative. IQR cannot be negative. Okay, and your, of course, your standard, your variance also won't be negative. So just be careful when you're doing that. Okay. Okay, so I would like you to take your time, finish this up. Just if you're not sure, I'm here. You can always ask me some questions. Okay, I'm gonna stop the recording here, and you will the next recording will continue on to the next few slides. So just scroll and check. All right. Okay, so now we'll look at question 2. You should have finished question 1. So question 2, basically transformation, it also involves conversion of units. Why conversion of units? Because you see this is in gram, then you're changing to kilogram, right? Which means you're going to divide it by 1,000. So it's the same thing. You don't need to go and change each data. You just change the mean and standard deviation accordingly. So if you divide 1,000, what will happen? Your mean also divide 1,000, standard deviation also divide 1,000. Now you want to convert to pounds. 1 pound is 454 grams. So if you want to you want to change from grams to pounds, what do? You divide 454. So your mean and standard deviation also divided by the same values. Now if I'm saying increase by 2.5 grams, what you can do is just listen to me first and then you can do it. Okay, I know it's a little fast. You just listen to me, then you can sit down and do the calculations accordingly, okay? Because I need to explain a few terms here that are important. So increase by 2.5 gram. What is increase? If I'm saying increase or decrease means you plus by 2.5. If increase, right? Minus is decrease. So when it's increase and decrease, basically I'm talking about change of origin. Okay, where it's just plus or minus. So increase means plus 2.5. Plus 2.5 means what? Your mean, you will plus 2.5. Okay, well, standard deviation will have no change. Okay. Next one. Increase by 5%. Now, whenever it's increase or decrease by percentage, that is always COS. Why? If you want to increase by 5%, basically you're going to multiply with 1.05. Original 100, you increase by 5%, 1.05. You decrease by 10%, it will be 0.9. You increase by 12%, it will be 1.12. So increase and decrease of percentage is COS. You times accordingly. Okay, but if increase by this much only is not percentage, then it is COO. So please make sure you sort that out, okay? I'll just go through the questions, okay? Then you have question 3 here, which will give you the mean and standard deviation. So here, I would like to show you something. Now, you want to find the mean and standard deviation, please just plug it all into the calculator. Don't do manual method, please. Make sure you write down in 4DP first, then you round it off. There is a reason why you need to do this step. Okay, I'll show you down here. So the mean is this much. You write it in 4DP first, then you round off accordingly. So now to report this data to a station, that it will be converted into Fahrenheit. So they're using this formula here, F equals to 9/5C plus 32. So one thing for sure, you know, one is times, one is plus, meaning both the transformations are involved now, times and plus. Okay, so for mean, how do you calculate? So when you want to find the new mean, what you have to do is you have to put the whole 4 decimal places into the formula. Do you see it here? 35.4286 times 905 plus 32. You don't forget to plus 32 because mean you times and you divide, plus and minus all affected. But if you don't transfer your values in 4DP, you can try. You will get quite a different answer. Only your final answer, you round off to 2 decimal places accordingly. Standard deviation, initially you got 4.1355, right? So you take 905 times 4.1355. Do you need to plus 32? No, because for standard deviation, no effect when you plus and minus, only when you times. This is a past year question. Many students make mistakes here. So please make sure you sort it out, okay? Always remember, standard deviation, only times and divide. Plus, minus, no effect. All right. Okay, so if you look at question 5, in this situation, a student was given a list containing 75 integers. So you know your n is 75. Okay, your minimum value is 15, maximum is 59. Everything you're reading, you just write it down. Okay, he enters values into the calculator and obtains a mean, which is 46. All right, and a standard deviation, which is 12. Okay, he was able to determine the median to be 49. So if they give you n, they give you mean, they give you standard deviation, you can find sigma x, you can find sigma x squared. That shouldn't be a problem. Okay, you can put it into a table or you can just write it down like that. He then checks all the data values entered into the calculator and discovered that a value was entered as 17, but it should have been 47. So what are you doing here? You're taking out 17 and putting in 47. Right, so from your sigma x, as I've showed you there, step by step, you minus 17 at 47. Sigma x squared minus 17 squared plus 47 squared. Okay, after that corrections, basically they're asking you mean, median, and range. Mean, the new mean you calculate using the new sigma x. Median, there'll be no change because the n didn't change. You just took out one value and put back another value. So the median will still be 49. How about your range? Your range also won't change because nothing to do with the first and the last data. Okay, so pretty much this is how you actually sort it out, all right?